this is recording. Okay, now I think we're ready to go. We've got to look at some higher order derivatives to wrap up standard 7. Higher order derivatives is another way to multiple different times. Nothing that says I have to stop with the first derivative. I could go into the second derivative or the third derivative and so on. Derivatives of derivatives of derivatives, yada, yada, yada. Some notation here. The first notation d squared y over dx squared. This is the notation for second derivative. F triple prime of x is the third derivative, taking the derivative 3 total times. Similarly, here's a notation in explicit form, d cubed y over dx to the third. After that, or even starting with 3, after that, you're just going to write the number in a quantity. F fourth of x, that's the fourth derivative of function f of x. Derivatives of derivatives. So let's take the second derivative of function f of x. Well, to get to the second derivative, what do I probably have to find first? First derivative. I can't get to the second before I know what to differentiate to get to that. So let's take the first derivative. F prime of x will be 40 x to the fourth minus 15x squared plus 4x. Derivative of 1 would be nothing. Now that I have the first derivative, I have the first derivative to get f double prime. Derivative again. Let's differentiate this first derivative to get to the second derivative. F double prime of x means take the derivative of the first derivative. So 40x to the fourth, using the power rule, that'd be 40 times 4, or 160x to the third. Minus 15 times 2x to the first, so that's minus 30x. What's the derivative of 4x? Starting with the 5th degree equation, the first would be a 4th degree equation, the second would be a 3rd degree equation. Once you get down to the 5th derivative, it's just going to be constant. Keep descending the power by 1. Try a little bit harder one. Y equals x over x plus 1. Let's take the second derivative of y equals x over x plus 1. How do I find the first derivative? What rule would be necessary to apply? Quotient rule, because I have the quotient of two functions, x divided by x plus 1. So if I sing it out loud to myself, low d high minus high d low, all over low squared. So dy dx equals low, x plus 1, times d high, which is just 1, minus the high function, so minus the x on top, times the derivative of the low function, which is just another 1. All over low squared, x plus 1, 1 squared. I have to build the first derivative before I can get to the second derivative. see, this would just be multiplying x plus 1 times 1 and x times 1, so that's going to be x plus 1 minus x over quantity x plus 1 squared. Obviously, what's going to cancel out next? Okay, there is first derivative. Now let's take the derivative of this to get to the second derivative.
Wait, why is it not like dy squared or d2x?
dy dx is the first derivative. Do you agree with me on that?
Yeah.
Okay. That's the same thing. I'm taking the derivative of y with respect to x. Now I need the derivative of dy dx. The derivative of the derivative would be the second derivative. So how many d's are there multiplying together up on top?
2.
2. D squared y. How many dx's are multiplying together on bottom? Notation's not super important, but that's kind of why it fits the order it is. Does that make more sense now?
Yeah.
It's not really a formula or a rule or anything, it's just kind of some common notation. All right, so let's do quotient rule again to take the derivative of the derivative to write our second derivative. Log x plus 1 squared. D high, what's the derivative of 1? 0. So that's nice. We're multiplying by 0. Minus the high times d low. Take the derivative of x plus 1 squared using power rule. Bring the 2 all the way out to the front, times x plus 1. The new exponent would be 1 less than what we started with. So I think I'm going to have it back down to 1 now. 2 times quantity x plus 1 to the first. Over x plus 1 squared squared. X plus 1 squared squared again is x plus 1 to the fourth. So obviously multiplying by 0 here means that that's pretty much gone. Negative 1 times 2 is negative 2 times quantity x plus 1 divided by quantity x plus 1. 4. One last thing to simplify or reduce down. I can divide through an x plus 1 from top and bottom. Once I divide top by x plus 1, it's just negative 2. Once I take one of the x plus 1s and x plus 1 to the fourth and divide that out, it's quantity x plus 1. Second derivatives have their own useful applications that we'll study more in a later standard, talking about the concavity of a function, how a graph is opening up or down, relates back to the second derivative. If you can take the derivative, you can take the second derivative because it's just the same process for another function. Questions there? Okay. Let me get you pointed on some more practice here.